Irodov problem 1.5. Two particles 1 and 2 move with constant velocities v1 and v2, both are vectors. At the initial moment, their radius vectors are equal to r1 and r2. How must these four vectors be interrelated for the particles to collide? This is a good vector problem. So let's say this is our frame of reference. Okay. And it says that we have a vector r1 and we have another vector r2 which represents the initial position of two particles 1 and 2. Okay. Now this particle 1 has a velocity vector v1. This is a constant velocity, right? So direction and magnitude both are same. And this particle 2 has velocity v2. Again, this is a constant velocity, same direction and magnitude. Now, how these four vectors need to be related so they can collide? What's the condition of collision? So just think of this. This particle 1 will continue in this direction and this particle 2 will continue in the direction where V2 is pointing. At some point they collide. Okay. Let's say the collision happens after time t. After time t. So then what will happen is this particle 1 would have moved a distance v1t in that time t, and similarly particle 2 would have moved a distance v2t in time t. Okay. So what that means is position vector of particle 1, if that is equal to position vector of particle 2, then the two particles will collide. So let's say to collision to happen, this is the condition. Initial position of particle 1 was r1. And we are adding v1t to that to get to this point. This point will be equal to r2 plus v2t. Let's bring the t terms to one side and let's take t common. So t v1 minus v2 is r2 minus r1. Okay, or t is equal to r2 minus r1 divided by v1 minus v2. Okay. Now look at this. These two are vector quantities. This is a scalar quantity. Time does not have a direction. Okay. When will the division of two vector quantities be a scalar quantity if the directions are same? Okay. So this can also be written as, if I do modulus, so we are only taking the magnitude of this vector quantity r2 minus r1 and we are dividing that by the magnitude of v1 minus v2. It should be the same result. Okay. Now just rearrange this. So r2 minus r1 divided by mod of r2 minus r1 should be equal to V1 minus V2 divided by mod of V1 minus V2. So this is the condition of collision to happen. Okay.